So I'd like you to meet Kent, everybody, today. So Kent is a senior geotechnical engineer and vice president of engineering at Trek Geotechnical Incorporated in Winnipeg, Manitoba. So Kent has worked in the geotechnical engineering field for 20 years in both the private and public sectors. He has worked as a consulting engineer at offices in Manitoba and Alberta. And prior to joining Trek, Kent spent 7 years working for Manitoba Hydro, with much of that time as the head of Manitoba Hydro's geotechnical engineering section. Kent has been employed with Trek since 2012. In addition to managing the engineering group, he also acts as a project manager and a technical reviewer for projects. Kent has actively volunteered for the CGS, the Canadian Geotechnical Society, throughout his career, and most recently served as the Vice President Finance for the National Executive of Canadian Geotechnical Society. And today, Kent will be speaking about his experience and the life as a geotechnical engineer in a design-build environment. So design-build or P3 construction is becoming increasingly common in today's world for large infrastructure and building projects. The projects are typically very large, tens of millions to multi-billion-dollar projects, and as such, represent significant opportunities to technically challenged designers and contractors, in addition to commercial rewards. They also represent significant commercial risk for both the design team and the builder. This presentation will provide an overview of the design build process, along with recommendations from the perspective of a geotechnical consultant on how to best navigate these projects and manage the risk. The presentation will conclude with discussions of a recently completed large build design project in Winnipeg. This presentation was previously given by Kent as a keynote lecture at the 6th Canadian Young Geotechnical Engineers and Geoscientists Conference in St. John's, Newfoundland. So if we can give Kent a big welcome.
Thank you very much. Thanks, Gabby. I guess to just kind of frame this talk, it's not a very technical presentation, but it was intended to give a bit of a different perspective on things to younger engineers at the CYGEC. Part of the goal of that conference is to kind of let people learn from more senior engineers' life experiences. So they asked us to talk a little bit about ourselves and some of our experience and some of the lessons we've learned over our lives. So I've just left those slides in as well, because I thought there might be some people here that would be interested in that sort of thing as well. So with that, normally I don't like to talk about myself very much, but I'm going to do a little bit of it today. So I've got my Bachelor's of Science degree from in 1997 and my Master's of Science degree in 2006, both from the U of M. I actually did a term of classes at the U of A here back in the early 2000s to complete my graduate degree. I worked in consulting for about 6 years before moving on to Manitoba Hydro, which is a Crown corporation, so basically arm's length government, for about 8 years, and then spent about the last 10 years at Trek Geotechnical. While I've been there, I've been the geotechnical lead on 7 different design build or P3 projects, with costs ranging from about $40 million to $500 million. So I have some of the scars on my back for some of the things I'm going to be talking about later on. So what I've learned through my time as a practicing geotechnical engineer and really trying to work with others, a big part of being an engineer is communication and teamwork. So if you're working with others, it's very important to try to understand where those people's motivations come from. It's very easy for people in different parts of the world to have very negative views of each other, and you see it quite commonly. I'm talking about people in consulting versus people in government versus people in academia. They can all have fairly strong opinions on each other, but the reality is that there's good people everywhere, and everybody really does want to do a good job. What is kind of a caveat to that, I guess, is different people have different definitions of what a good job is. So if you can understand, what's driving that person and where they're coming from, it's going to help you work with them better. I say this to all of our junior staff. We can teach you the technical skills. You've gotten through engineering quite often when we're hiring people that's with a graduate degree. Obviously, we're all smart people. We can figure all this stuff out. But what can't be taught is attitude and character. And they are more difficult to change. A positive attitude is going to go a long way throughout your career. And finally, honesty is always the best policy. Except for me, I don't think I've ever met anyone else that's perfect before. Please laugh too, by the way, these are really funny jokes. Anyways, everyone makes mistakes. The most important part about making a mistake is if you do so, own up to it right away. Don't let it, fester and become worse than it already is. And if you've made a mistake, the best thing you can do is go to whoever you report to, or whoever, the project managers for the job, and say, oh, I've made a mistake, here's what I've done, and here's what I think we have to do to fix it. Don't just go with the problem, try to go there with a solution as well. It's going to go a long way. So particularly as a younger engineer, take opportunities when they present themselves. I know that's a bit cliche, and I'm not the first one that's ever said it, but quite often these challenges can be, a little intimidating. They can require a lot of long hours, travel, or risk your career, even if it's a difficult job that you're kind of sticking your neck out on. But it's always going to be worth it, and you're always going to learn, which is the most important thing you can do. I always tell everyone to work in the field as much as possible in your first few years. It's valuable to understand how drill rigs operate, how excavators dig, how bulldozers work, where they're going to have access issues, what kind of slopes you can travel up, all of those good things. So making sure that you have that background is just going to prove valuable throughout your career. Unfortunately, this often means travel. We've got to go to where the project is, but I would just suggest you embrace it. I've spent a ton of time on remote locations throughout Northern Canada, and often, there can be some difficulties with that and some challenges personally, but some of my best experiences have come from that time. So I would recommend that you all take those opportunities when they come and embrace them. Exceed expectations. It's another really hard one to figure out yourself, but the best way to get opportunities and get new challenges is to deliver high quality reliably. And what that means is check your work. If you're giving something to a supervisor or a project manager, the expectation should be that you think that's ready to go to the client. So that means that it's clean, there's not a lot of comments in it, there's not a lot of track changes. This is a camera ready report to go to a client or a paper or whatever it is. And finally, if you commit to doing something, make sure you do it. That's not always possible, but if you say you're going to do it, figure out a way to get it done. If you really are in a dire straits, you're going out of town for another project, make sure you've communicated the fact that you're having difficulties and get support. Saying you're committing to doing something doesn't necessarily mean you have to do it, but you have to make sure that it's taken care of. So it was mentioned that I've been volunteering for the CGS, or the Canadian Geotechnical Society, and I've been a member since 1998. And pretty much volunteered continuously since that time. I spent about 6 or 7 years on local organizing committees, a couple of years with the Geotechnical Society of Edmonton there. Served as a publicity chair for the 2003 CGS conference and technical chair for the 2012 CGS conference in Winnipeg, and co-chaired the third CYGEC. I'll even help Kevin out here and put a plug in that the Canadian Young Geotechnical Engineering Conference, or the YP conference, is being held in Banff before next year's annual CGS conference in Calgary. And I'd encourage all of you to try and get there, because it's a great experience and it'll definitely be a positive impact on your career. I was a past chair of the Professional Practice Committee, and as was mentioned, I just completed 4 years as the VP Finance for the Society. So I think one of the things you'll see there is that as I progress through my year, I've gotten larger and better roles. And again, that comes from following up on what I committed to and making sure that you're delivering. What I learned from the CGS, staying involved, has benefited me greatly throughout my career. I've met a lot of good people, and those connections have benefited me many times on past projects. So just recognizing or knowing who I can call if I've got a technical challenge, and having that network has always proven valuable. It's helped me to justify attendance at national conferences. I've been lucky. I think I've only missed about 2 in the last 20 something years. So being able to go to that conference allows you to be able to learn and stay on top of new approaches in the field, and just stay technically on point. It's also kept me very excited about my job. Typically, when we're dealing with folks in the CGS, there's a lot of good people, and getting to network with them and getting to know them better gets you more excited about what you do. and more proud to be a geotechnical engineer. And in the private world, it's also helped me to win projects. Some of those connections that I mentioned have actually helped me to win some fairly large contracts for Trek. So a lot of benefits to membership there. I've spent a lot of time on volunteer duties, but I've definitely received more in return. I'm definitely not the first person to say that either. Apparently, I'm just going to rehash what others talk about. The first person I ever heard say that was Dennis Becker, but I can't fault him for that. He's absolutely right. And again, finally, if you commit to doing something, even in a volunteer world, you still do it. You only have one reputation, and you want to make sure that you're presenting yourself properly. So on the final side of me, I guess, is who am I? I'm a husband and father to 2 boys. My oldest guy is 13, and in my opinion, he's probably the best kid in the whole world. My youngest guy, Max, is 11, and in my opinion, he's also the best kid in the whole world. Max was also born with several health issues, which I'm not going to get into in a lot of detail, but I will say it's given me a bit of a different perspective on my work career. Having gone through having a kid with critical illnesses, it kind of gives you a different perspective, and it allows you to kind of step back and recognize that, you know, going through a tough time at work right now, but it's not the end of the world. You're going to get through it. The reason that we talked a little bit about this at the CYJEC is one of the things they wanted us to talk about was the challenges of balancing both work and personal life, and it is a challenge. I can honestly say you're never going to be able to find the perfect balance. But the real key to me was trying to find times and recognizing what should be sacrificed at certain times. So in some instances, I've had to go out of town and been away from my family for a while. And in other instances, I've had to turn down out of town work because I had an important family event that I had to take care of. So trying to find that balance, generally, like I said, it's a challenge. Generally, if you're making somebody unhappy, you're probably doing it right. So sometimes a crisis at work is really not as bad as it seems. And that, again, I guess goes back to the sick kid comment. And I've talked about that a little bit. Really, if you're in a situation, the worst thing that you can do is panic, because then your brain shuts off. Just take a step back, take a few breaths, kind of recenter yourself and dig into the solution. So being a geotechnical engineer gives you all sorts of different opportunities. I've managed to get to Egypt at one point in my life to attend an International Young Geotechnical Engineers Conference. I've got to travel in some helicopters. I put that picture in there because I just think I look really cool. I've traveled around to some oil sands sites. I've got to see polar bears up in northern Manitoba. So I've gotten to see some pretty neat things through this career. I've also got to work on some pretty neat projects. That upper site is one of the first design build projects I ever worked on when I started at Trek. And we basically were building a construction camp for 2,500 people in the middle of nowhere in northern Manitoba. So this photo here on the left is a photo of the site that I took from a helicopter our first day in to go in and start walking around the site and do some hand auger exploration in kind of the first stages of trying to figure out what the site development would look like, how much peat had to get stripped, that sort of thing. And the site on the right is nearing completion of piling, where we threw 5,000 helical piles in the ground by the end of the project. So I always joke that there was 2 piles per person when you stayed in that camp. I've got to work on some very large diameter caissons. I've built some large interchanges. This is again another design build. Well, all of these are design builds, I guess, in these two. This was for a large converter station in Winnipeg. This was for a large interchange in Saskatoon. And finally, I got to work on some pretty neat large northern hydroelectric projects as well. So this is the Long Spruce Generating Station in northern Manitoba. I've also had some fun. Unfortunately, I think the photo on the left comes from when I was in Egypt, and my stomach's gotten a lot bigger since then, so I could probably beat that guy. Caught some big fish, and this is just a photo of my family. We got to do a toy dash at Toys R Us as a result through the Starlight Foundation, where my kids got all the toys they could pick up in, I think, 10 minutes at the Toys R Us. So, pretty good experience there. And this I added at St. John's, kissing the cod. So if you ever go to St. John's, it's a rite of passage. So anyways, that's enough about all of that stuff. Hopefully some of you enjoyed some of that. On the show, a few ground rules, I guess. I will be switching between metric and imperial. It's a danger of the job in the design build world. You're dealing with a lot of contractors, and they prefer foot trick to metric. And finally, laugh if I tell a joke. And I really mean it, please laugh. I guess the other thing I didn't mention at the start of the talk, but if anybody has any questions as we're going through, just feel free to stop me anytime. I'm only got about a 40-minute presentation. I'll probably ramble on a little longer because I tend to do that when I'm in front of people, but we'll have lots of time for questions, so feel free to interrupt me anytime. So I'm not sure how much you guys know about the different contract models or how much people have been exposed. I'm sure quite a few know about this already, but the historical model that's been used for most projects in Canada is the design bid build model. And that's really where the owner defines a project scope, goes out, hires a design team, completes the design, tenders projects with specs and drawings that a contractor then bids on and then is awarded the project. And then the owner or the consulting team oversees the project on behalf of the owner and basically just administers it and makes sure the contractor's meeting specifications. The design build world is a little bit different. Owners define the project scope and then they tender the project. So they're tendering it directly to contractors who then go out and hire their own design team. The contractor then is required to bring the design to about a 30% or a preliminary design level, just enough you want to do the bare minimum to accurately price the job and ideally be the low price so that you get awarded the contract. There's a bit of a variation to the design build, and that's the design build finance maintain, or a P3, public-private partnership, where they add on a finance aspect to that as well and a maintain aspect. So in that case, you would design build it and then maintain the project for some set period of time that's laid out in the contract documents, typically somewhere in the range of 25 to 30 years. And during that process, you're required to maintain the project's performance the entire time. So why do owners want to look at design builds or P3s? The primary driver that I think anyways is that they provide cost certainty to the owner. So when your contractor is bidding on a design build project, they're basically committing to a lump sum price for the work. Barring any major unforeseen conditions, they're held to that price regardless of what happens. So there's definitely that cost certainty aspect. Schedule wise, they tend to be completed faster than a historical design bid build. They come with tight schedules, and that's part of what I'll talk about later on. They tend to be fairly labor intensive when it comes to schedule. In theory, the model should drive innovation. So you're challenging contractors to come up with the lowest possible price. And if they can come up with an innovative way of building something, they're going to do it cheaper. I say in theory because quite often what ends up actually governing the project is schedule. And in that case, you know, innovation can actually be viewed as a detriment because there's some risk that comes with trying something new because you don't know if anyone's ever done it before. So problem, it's going to be, you know, potentially schedule risk. Particularly in the P3 or the design build finance maintain world, there's a theory out there that life cycle costing is better evaluated. So the contractor who's actually going to be taking care of the maintenance has to price all of that into their bid. Quite often they have a better understanding of what those costs look like. So that life cycle costing is better evaluated. And finally, the final for a P3, again, there's a deferred investment aspect. So one of the things that I learned in my government time was that money not spent today is money saved. So if you can defer investment through something like a design, build, finance, maintain, where you're not having to come up with, say, 500 million capital on day one, you're coming up with 500 million capital over a 20-year period. It's a lot more manageable for a government entity or an owner. So those are the benefits, and that's why we're seeing a lot of them in the market today. But there's challenges with the design builder or P3 as well. The biggest one is probably that when the project is awarded to a contractor, the design isn't finalized. Like I mentioned previously, we're preliminary design. The number I've always heard is 30% design. But that means that there's a lot of risk being taken on by both the contracting and the consulting teams when they get involved in these projects. You can imagine that there's a lot of opportunity for surprises in design and construction in that remaining 70%. As I said, schedules tend to be very aggressive, which means you're putting in a lot of hours. And from a consulting perspective, I found you can expect a lot of design iterations. So what I mean by that is during the pursuit phase, the contractor is pushing very hard for you to come up with the best possible design so they can get the lowest possible price, because that's how they're going to win the work. It's generally, not always, but generally governed by kind of a low bid process. So whoever's the lowest price gets the job. So that means that you're submitting designs to the contracting team. They're coming back and saying, would this be cheaper? And I'll take a look, redesigning, resubmitting, coming back and forth a couple of times. And then it gets submitted to our end client or the owner, and they review it and say, oh, we're not sure about this. And then it comes back again. And that's just to get the project. After award, they've committed to that price, but they're still looking for opportunities to save money, because every dollar saved is another dollar in their pocket. And what that means is there's a lot more questions that come, and you basically are iterating that design constantly throughout the life of the project. You can also, go ahead, Kevin. It's a risk. There are contractors that have tried that in the past and probably been successful, but there's also contractors that have probably tried to have change orders get through and they didn't get them, right? And if you don't get that change order, that's a huge issue as well. So yes and no. Yes is the short answer. It's definitely that is one of the risks and one of the aspects of the job. Like nowadays, in my experience, you really have to prove that there's a changed or unexpected condition in order to get that change order through. And if there isn't strong evidence of that, you're going to end up in a court probably discussing it. So does that answer your question? So there can be challenging dynamics between designers and builders. Again, historically, and what I was always used to coming up was the design bid build world, where you're kind of used to saying, this is the design, you have to build it. Now we're working for the contractor, and sometimes you're forcing them to do something that they really don't want to do because it's costing them money. And while you're costing them money, you're billing them for it. So it can create a bit of an interesting dynamic there. And the last one that I'll throw out there is really what the owner's role should be on a design build. Again, owners are more used to the design bid build world in a lot of the aspects, and they want to have a really hands-on take on design. But in a design build, you should really be looking at a performance-based specification. You shouldn't be saying, I want this many hunks of rebar in the bottom of this girder. I talk a lot about bridges because that's what I do a lot of work with. But it's not coming down to that level of design. They should be saying, I want a riding surface on the bridge that allows this car to go over at 80 kilometers an hour with a riding index of blah, or something like that, right? So it really should be about how that bridge is going to be performed and not the specifics of the design. Having said that, owners have some pretty strong opinions. They've been doing it a long time and understand how these things work, and they want to make sure that the design is done properly as well. So you end up with a lot of interaction that I think really doesn't meet the spirit of this. So I think putting the bug in anyone that ends up in government at some points here, that owners really have to think about what their role should be when they get involved in these projects. So just talking about the various stages of a design build, the first stage really is the functional design. And this is completed typically by the owner or by a consulting team that becomes ultimately typically the owner's engineer. And this is very high level design. So again, in the thought of an interchange, because that's where you see a lot of these, you're looking at a general geometrical alignment for the area so that the owner can go out and acquire all the land that's needed for the project, that sort of thing. Very conceptual design level of crossing locations, collection of some baseline geotechnical data, so some test holes to allow the contractors to adequately build the project. And then final stages, once you've got that conceptual design done, preparation of requests for proposals and technical schedules for the project. So the RFP and the technical schedules for a typical large design build generally ends up being a book about like that. It's like 1,000 pages of specifications and performance requirements, and you name it, it's in there. It talks about which codes you're building to. Is it the Canadian Highway Bridge Design Code? Is it the National Building Code? Is it the AASHTO? Depending on where you're, and in the case of a BBFM, it's what those performance requirements are for the whole full life cycle of the project. So that's kind of, at that point, we've got an RFP issued, and that's really where the contracting side of it starts. So they issue this RFP. I should say, I guess before they do that, there's a pre-qualification process. So they typically will issue some information to clients, or to the contracting teams, and contractors are required to pre-qualify for the work. Typically, owners are looking to shortlist 2 to 3 contracting teams to bid on the project. And the reason for that is there's typically an honorarium that owners have to pay out in order to get a contractor to bid. So depending on the size of the project, it's typically around $50,000 to $200,000. Again, depending on the overall budget of the work. So the owner has to shell that money out just to get a price from the contractor. It sounds like a lot of money, but in my experience, the contracting teams I've been involved with, if it's a $200,000 honorarium, are probably spending closer to $3 or $4 million to get that design to that point. There's a lot of work that goes into it. So there's a lot of investment that goes into these, so they don't want a lot of firms involved. There's also a lot of, like I said, design iterations, interactions with the owner. So it creates a lot of work if they have a lot of contracting teams. So they shortlist 2 to 3. The good news is, from a geotechnical consultant perspective, it's a relatively painless process. We have to come up with a statement of qualifications for our team. So that's, CVs, company descriptions, some very high level design assessments of the project, just identifying any key risks that you're going to address. The downside of the geotechnical consultant world is that you've got very limited control over whether or not you get shortlisted. The money and the project itself is really being driven by the contractor. So the best thing you can do as a design consultant is make sure you're hitching your wagon to the right horse. It's really looking at, if you've got an option of multiple contracting teams, which one do you think you want to work with? Which one do you think is going to, provide the best relationship? Which one do you think is going to win the job? And trying to balance all of those things. Because typically you can't be on multiple teams. You're assigned exclusively to that one contracting team. There's a lot of confidentiality associated with these things, so they don't want you working on multiple teams. The last thing you do as part of your submission typically is prepare and provide a pursuit geotechnical design cost estimate. So this is a lump sum cost estimate that you're submitting to the contractor and committing to come up with that 30% or preliminary design level during pursuit. So our contracting team was successful, we're shortlisted, and now we're into the pursuit phase. So that's that preliminary design phase. It's generally a relatively short period. I've seen it around 4 to 6 months. So that's 4 to 6 months to come up with preliminary design for, a multi-million to billion-dollar project. It's a very intense design period. You've got very hard deadlines you have to meet throughout. Particularly, again, for a geotechnical consultant, everybody needs our information before they can go ahead with the structural design and the foundation design and the geometry design, because we have to give comments on embankment slopes and things like that. So we're under the gun immediately to get some information out. So the design is preliminary, but you have to capture enough detail to permit accurate price. And again, the number is 30%. The design submission's reviewed by the owner, and it has to be technically compliant. So the owner has to say, yes, you have met our technical requirements. You are now, approved for that design, and then the contractor submits their price. So the biggest role I see here, aside from providing design recommendations to prevent that design to go through, is we have to identify the risks that the contractor is taking. And those are risks that are quite often implicit in our designs, right? So it's the assumptions that go into all of the math that we do, that we have to present and explain. Here's how we've assumed this, and if it deviates from that, here's the risks, or here's what the cost implications could be. So when I talk about pursuit, I think of it as probably the most important part of the project for the design team. This is where you're handling a lot of the risk for the project. If you've missed something big and it's going to cost a lot of money, you're probably going to have problems. Following pursuit, the entire team is committed to that price, and it's often with limited soils information. There's always more information that you're collecting following award. People don't want to invest the money at the pursuit phase for obvious reasons. If they don't get the job, that's lost money. If you miss something big, it can result in serious repercussions, which will be legal claims or insurance claims or project write-offs. You have to make sure that you've got construction inspection requirements well established in your pursuit costs, because if you haven't told them how much it's going to cost you to inspect it, they're not going to want to pay you to do so. Along with that, you also have to talk about what kind of exploration costs are going to be required and monitoring requirements. So if you're building a large embankment and you didn't tell them it includes settlement monitoring in that project scope, you're going to have a very hard time selling that, and you may be installing it on your own dime otherwise. So you have to make sure I've identified all of these things when you submit that price. So once we've got our design done, the final stage again is we've got to provide our budgets that we're being held to, again, typically on a lump sum, which I've always had a big problem with in these. So we're talking about construction inspection now, so it's totally at the mercy of the contractor schedule, but we're expected to commit to a lump sum price. So I have no idea what rate these piles are going to go into the ground, or you know, how many contracting teams are going to be out there, but they want me to tell them exactly how much I'm going to charge them to do it. You can expect a lot of emails and a lot of meetings. There's a ton of communication that goes into these things. And the design should be documented in a report. In my experience, contractors don't necessarily require you to submit a pursuit geotechnical design report, but if you ever get involved in one of these projects, I strongly recommend that you do it. That's a document where you summarize everything that you did to complete that design. You list all of your assumptions, you identify all the risks the contractor is taking that are implicit in your design, and it's all documented and presented to them during the pursuit phase. That way, if there's a problem later on or there's any uncertainty about what was said, you can always come back and say, oh, look, I have it in black and white right here. I told you exactly what was going on. So we went through pursuit. Our contracting team was awarded the project. That's when the panic really sets in. You've got to complete detailed design, drawings, and specifications for the project. Again, quite often the contractor's on a very tight timeline. So they're looking at some aspect of the project that they can get working on in the field right away, which means you've got to scramble to come up with some quick designs to get them to get shovels in the ground. So quite often that construction in some areas proceeding while the rest of the design is still underway. Your contractor is committed to a schedule and a price, and so are you. And it's important to manage scope creep. There can be a lot of back and forth. And like I said, you're committed to a lump sum price, so you have to manage that back and forth. You don't want to nickel and dime folks and say that, oh, no, I've already told you this, I'm not telling you again. You have to keep everybody happy, but you also have to do it within a budget, and it can be a real challenge. It's a very intense period for everyone. Again, deliverables have to be on schedule, and they're going to be subject to intense scrutiny. It's a challenge, again, as well as a geotechnical engineer, because not only that preliminary area to get shovels in the ground, but the overall project, the entire design team is waiting on our recommendations so they can get going and finalizing their designs. You can expect your emails to increase to hundreds per day. You get emailed on everything. I just had a, you end up, quite honestly, on some of these, you can't even read all the emails. You have to look at the subject line and say, yeah, that one doesn't really affect me. I'm just going to ignore it and hope it doesn't. Some will follow up if they need to, because you just don't have time to do the work and check all the correspondence. And you can also plan on being in many more meetings. You spend a great deal of time talking about work instead of doing the work. So that's really going through the entire design build process and what that design looks like. And I thought I would try and kind of frame it into a project that I completed 2020, I guess now. It's getting a little older. But it was a Southwest Rapid Transitway Stage 2, which was just completed in the city of Winnipeg. And what I'm showing here is basically the transitway alignment that was running through. This represents about 10 kilometers of transitway through an urban environment, so it was all fairly brownfield, close to a lot of existing rail lines, so there was all sorts of interactions with rail, which was a challenge. This is the football field, home of the Grey Cup winning Winnipeg Blue Bombers. I just wanted to point that out there. And so the transitway corridor linked that football field in South Winnipeg to kind of closer to central Winnipeg. So the project involved 9 bridges, 2 pedestrian bridges, 1 rail bridge over CN's main line, which is always a bit of a challenge to build on the main line, 2 rail underpasses, and 4 transitway bridges. It was a P3 or design, build, finance, maintain project with a 30-year lifespan. And the total price tag was approximately $450 million. This was the biggest DBFM, and I think it still is the biggest DBFM that's ever been constructed in Manitoba. doesn't really measure up to the Hen Day, but it was big for us. So the overall lead for the project, just to acknowledge the partners, was Plenary Roads. So they really brought the finance and the maintain side of the project. The lead contractor was PCL, and our design team consisted of Tetra Tech for the Transitway bridges and overall project management, Hatch for the rail bridges, and Morrison Hirschfield for the transportation design. My company, Trek, was hired to support the entire design team for geotech. So we did all of the geotechnical design for all of the structures. And to give you an idea of the project timeline, that functional design study was completed or started in 2013. Pre-qualification for the project for the contracting teams was completed in 2015. That project pursuit or preliminary design phase was completed in 2015 as well. The design team was given about a 4-month period to come up with that 30% design for the entire project. The project was awarded in 2016. Following that, we did, as I mentioned, have some existing geotechnical information that you always do, but we had to get out and drill 20 test holes, complete all of our advanced lab testing, and issue 11 design reports in the first 3 months of the project in order to keep everybody else on schedule. Construction also began, as I kind of said before, at the exact same time we were still out, we were still spinning augers into the ground while construction was underway. And we finally completed construction in 2020. So it was a big job. So I'm sure a lot of you aren't familiar with the local geology in Winnipeg. We had about 10 to 15 meters of high plastic lacustrine clay over most of the project, which tends to be fairly stiff and over consolidated near surface, becoming soft to very soft with depth. Quite often, just very lightly over consolidated to normally consolidated in the deeper portions of the deposit. Really what this means is that we had settlement concerns for any fill embankments we had to construct. And we also had low shear strengths, so we had to think about that when we were thinking about abutments, slope stability, approach fill stability, all those sorts of things. That's underlain by about 2 to 6 meters of dense glacial till. There's actually 2 till units that you commonly encounter in Winnipeg. There's a glacial outwash till, which is kind of a water-laid till near the surface, and underneath that is more of a basal till. It's hard and dense. Because of the nature of till placement, it's known to commonly contain boulders, and also seepage and sloughing conditions are encountered when you're drilling holes. So those can all cause problems when you're dealing with foundations. And then that's underlain by a dolomitic limestone bedrock. So the bedrock in Winnipeg is significantly fractured in the upper 2 to 3 meters and tends to get a little bit better with depth. However, the depth of the rock and the rock quality can also be highly variable. So when the contracting team is trying to figure out what the cost of piles is going to be, it can be, challenging because there's a lot of risk there. We had instances, I think, where piles extended about 10 to 15 meters deeper than we thought we were going to have to core at the pursuit phase. So that represents significant cost risk. You can also have high groundwater pressures within the bedrock, particularly in that upper fractured zone. It's not artesian in most cases, but it's pressurized. So it's not going to go above ground surface, but it might get close. To give you an idea of what rockcore typically looks like in the Winnipeg area, what we're seeing here, is this upper portion is actually the lower portion of the till. So you can see we cored through a large boulder, but the till is dense and intact enough that you can actually core it without losing a lot of the material. That's kind of underlain by this highly fractured limestone. And then below that, we're getting into what we typically call good limestone, which again, you can see it gets better with depth. Although we do see areas like this where we've got some clay infilling and things like that, which can cause some heartache if you're trying to build a caisson. You want to make sure you don't have anything like that right below it. So when that's a little bit about the geology. So when we're looking at all the bridges that we looked at for the project, all of them were founded on bedrock, which is fairly typical for the Winnipeg area. They were founded on a combination of either driven steel H piles, which typically are able to get driven through the till and just kind of seep themselves into that bedrock. We did PDA testing to make sure that the piles were getting the capacity that we needed. The other option that we had was large diameter caissons, so rock socketed caissons. The reason that we went with a combination is rock socketed caissons tend to be very expensive. The numbers that I've heard are anywhere from $40,000 to $50,000 a caisson in Winnipeg, whereas a driven steel pile is typically in the range of $5,000 to $10,000. So even if you've got to put in multiple driven steel piles, it's still more cost effective. But in some cases, you've got space requirements or constrictions that wouldn't allow driven steel to proceed, and that's where we went with caissons. Approach fills were required for quite a few of the bridge approaches, and we had to look at settlement mitigation. There was some fairly strict requirements with respect to differential settlement between the pile supported bridge structure and that approach fill, which is very common. Typically, it's somewhere in the neighborhood of an inch differential settlement is all that you're allowed to have during the bridge performance, so on the in-service date. So to mitigate that, we looked at a few different things. We looked at EPS foam blocks for pedestrian bridges. That's basically the commercial name for it is typically that you see around Canada anyways, geofoam. Manitoba is a little bit different than Alberta. Alberta will allow you to put these, I believe, into vehicle bridge approach fills. They don't allow that in Manitoba, and it's an argument we've had a few times over the years, but never won. There is some concern that geofoam or EPS foam blocks can break down if they're exposed to hydrocarbons, so they've always kind of been opposed to doing that. There's ways around that, and I think, like I said, it has been successfully done by ATU on many projects. So in the areas where we weren't allowed to use EPS foam, we went with lightweight cellular concrete, and again, the commercial name that you often hear for that is CEMATRIX. Quite often with MSE wall facing on the outside of those CEMATRIX embankments, just to limit the footprint and the quantity of CEMATRIX that was needed. Everyone knows what MSE walls are, I'm assuming. You've seen that in your classes, mechanically stabilized earth. And then for some of the very large approach embankments, which I'll show some pictures of here in a second, we went with rigid inclusions and wick drains. So this was kind of a design build within the DBFM that was completed by Menard with controlled modulus columns, which was the first time these have ever been used in Manitoba. So that was, we talk about innovation, that was an opportunity to bring something new to the Manitoba market. And really what those are is basically cast in place concrete piles bearing in that glacial till that are supporting the embankment. So there's piles go in, there's wick drains between the piles because some of that load is still going to get transferred to the underlying clays. So you need to accelerate settlement still. And then you're putting this load on top. You also need the wick drains because there's actually no cuttings that are developed with the controlled modulus columns. It pushes all that clay to the outside. So you're generating a lot of excess pore pressure as you're pushing that probe into the ground in order to build the shaft. And then we had some stability mitigation still required at some locations, and we really addressed a lot of that using really high strength geogrids or woven geotextiles. So we put geogrid reinforced layers in order to drive that slip surface back to increase the global stability. So that's it. I know I had a lot of text on all those slides. That's because I'm not very good at PowerPoint, to be perfectly honest. But I'm ending it with some photos here just to give you an idea of what I was talking about on these projects. So this is where the lion's share of the work happened on the project. It's known as the Portage Junction, but we were basically, this is what it looked like in 2016 before we started the project. We had the existing CN main line over, this is called Pembina Highway, which is one of the major thoroughfares through Winnipeg. And then this was the first stage of the Transitway corridor was constructed to this point and stopped. And our job was to extend it past in this area. So basically, in order to get a Transitway corridor through here, we had to realign the rail slightly to the east. The good news is that the rail bridge in this location was also nearing the end of its service life and required replacement. So that was tacked into this project as well. So this is what it looked like close to the end of construction. You can see that we've shifted over the rail line. We've got our new rail bridge. We've got our new Transitway bridge. And then we actually had to come in and duck underneath two other rail lines with underpasses. So this was a really tight construction area to get all of this work done in such a tight time frame. And it was honestly, the logistics of trying to keep everybody working in such a small area was probably the biggest challenge with this whole project. The next bridge that we looked at was the McGillivray Overpass. And here you can see we've got these very long gradual approach fills that get up to about an 8 to 10 meter height. This is where one of the sites where we use the rigid inclusions or the controlled modulus columns. So these embankments are pile supported the entire length back up until the embankments get to about below 2 meter height. The bridge in this case was supported on rock-socketed caissons at every location. The bridges on the last slide, I forgot to mention it, but they were a combination of the driven steel and the rock-socketed caissons. Sorry, why don't I go back one more thing here too? I did also forget to mention abutments in this case for a variety of reasons, but we went with CEMATRIX or lightweight cellular concrete abutments on the south side of these bridges. We went with geogrid reinforced embankments where we weren't placing as much on the north side in order to meet stability requirements. And then we had a little bit of cellular concrete that was placed on the approaches for both of the rail lines. This is the Winnipeg Overpass. It looks fairly similar to the last one. And this is, in my mind, one of the strangest bridges in all of the city of Winnipeg now. It's right in behind us. Basically, there's a small industrial area, but it's largely residential kind of area. And this is kind of off of Pembina Highway, and just in the middle of nowhere, there's this gigantic 5-span bridge that we built. And it was really constructed so that we could fly over some spur lines for rail. Particularly, this line runs to the United States and is a fairly busy line. So again, this entire bridge was founded on rock-socketed caissons with controlled modulus columns for the approach fills. And then getting into Bishop Grandin Crossing. So this is another major thoroughfare in the city of Winnipeg, and we had to construct a pedestrian bridge and a transitway bridge kind of side by side, kind of complicated by the fact that we had some large overhead hydro lines right over our bridge abutment at this location that we couldn't mess with. So we were able to get driven steel piles in at these locations. So these are driven steel pile supported embankments, or sorry, piles or abutments and piers with, again, CEMATRIX embankments with MSC wall facing on this side, and basically just a sloped abutment here because we had to get a pedestrian path in underneath it. I haven't shown the Bombers Stadium bridge here because I didn't want to rub too many salt into the wounds about our glorious victory from a couple of years ago. So with that, I'll really just open the floor to anybody that has any questions about anything, and hopefully I didn't bore everybody too much. I always like to end with this slide, which really highlights why university education is important. So it goes back to my hydro days. Thank you very much. Go ahead. Yeah, so it was done as a kind of a design build, and it's very proprietary the way that Menard handles that stuff. But they did do a full load testing program. I think they tested individual columns and groups of columns in order to assess. They didn't test each one, but they did some preliminary load testing to get an assessment of behavior, and then did some, I think, trial tests as they went through it. It seems to have performed very well and kind of met all the performance requirements. It's been in for a couple of years now. So, if you have any questions, well, Kevin. I've always wanted to be on the owner's engineer side. I've never managed to do it. I've always had a joke with my colleagues that owner and engineer are paid by the question, so that's why you get so many of them. But it can be a challenge. Everybody, particularly in our world, has a bit of a different way of doing things, right? So in my mind, the role of the owner's engineer is to identify things that are going to result in significant consequences to the project, and shouldn't be sweating the details of how it gets to that point. It was one of the things I learned from my time at Hydro as well, where I was quite often acting as an internal owner's engineer on projects. And when I first started, I thought I was adding a lot of value if I came up with a whole bunch of questions and tried to show how smart I was, until I realized that all I was doing was costing my company money because someone was going to have to answer all these stupid questions. So, you know, after a couple of years of that, I realized that really my job is to identify deal breakers and huge risks. And aside from that, don't sweat the small stuff. So I think if you're going to be on the owner's engineer side, that's something you should think about. Is this just a different way of doing things that you don't necessarily agree with, but it's probably going to work? Or is this a real risk? Does that answer your question? So I didn't mention it, but the owner's engineer in this case was actually Golder. They did an excellent job with the baseline geotechnical design report. So we had a lot of information going into the project, which was always useful. But we also, we took our design far enough during that pursuit phase that we knew kind of where we had our gaps and we had all of our test hole locations that we wanted drilled, identified and priced as part of our submission when we submitted to the client or to the contracting team. So yeah, it was all basically predetermined. Sure. I would suggest the answer isn't to say no. It's to say, oh, geez, I've got a lot on my plate. If I'm going to get this done on time, something else is going to have to get slide. So, these are the priorities on my plate right now. Which one of these is most important? If there's something that can slide, let's discuss that. Or if there's something that needs to be handed off to free me up to do this job, which I really want to do, let's talk. I've never really liked it when people say no. I like it when people come to me with solutions, like I was trying to say before. I would rather have someone be honest and say, I don't think I'm going to be able to deliver on this early on, though, than let things get to a situation where it becomes absolutely critical and we're all working with them. I've seen that happen as well. So hopefully that answered your question. It's not an easy one, right? No one likes to say no to their supervisor or their whoever it is. So. Well, we all tend to be fairly keen people, so it's not really in us to say no. We're all very eager to please. Is kind of my experience with the engineering world. So trying to balance that eagerness to please with a dose of reality can be a challenge. So. They seem to accept them fairly readily. With the understanding that there was going to be some load testing to prove the concept out and some settlement monitoring to prove that things were working as expected, they accepted them fairly readily. Particularly in this case where we're dealing with a design, build, finance, maintain. At the end of the day, if there was excessive settlement, it's probably going to be on the contracting team to fix anyways. The city would just have to come along and say, I've got a bump at the end of my bridge. I don't want it there. You guys got to fix that. Right. So it really threw a lot of that risk back on the contractor. And there was enough financial incentive there that the contractor was more than willing to take the risk. So it was a very cost-effective solution in that case. So.